any one of your faces. But while the recording is going on, I will be able to see your face lah. Okay, and as much as possible, I will try to avoid putting up your face on YouTube. Okay, so let's begin. Thank you. We want to begin our new chapter, chapter 5. Okay, today is mostly listening because you guys don't have the textbooks yet. So as much as you can, try to concentrate on what you're seeing in front of you. Can you see the slide that I'm showing now? So there's this guy that is... Can see?
Yes.
Okay. Wow. Okay. So this is a continuation of our chapter 1 in Form 4. Okay, which is Forces and Motion 1. Okay, and which I said much earlier that one of the most important things that we learned in chapter 2 in Form 4 is the Newton's second law. Okay, which is force equals to mass times acceleration. And then this force obviously is not just satu force sahaja, tapi we call it a net force. Okay, dia adalah hasil jumlah all the forces that are there. All the forces that are involved in an organism. In moving an organism, moving an object. Okay, and then the second thing that we established from our ulang kaji is the concept of how, if there is an acceleration, the net force is there is going to be a net force lah. Dia bukan sama dengan kosong. Okay, but if the net force is zero, okay, if the net force is zero, this means two things, that there is no acceleration. Okay, the acceleration is zero. And when there is no acceleration, there is two situations where this can happen. Number one, the object is stationary. Okay, and secondly, the object is moving with a constant velocity. Dia masih bergerak, okay, cuma dia tidak memecut. Okay, so this is something that you must set in your mind when we are going into this chapter, because if sampai sekarang kan kalau ini saya balik-balik cakap kan, tapi masih lagi belum termasukkan, it's going to be tough lah. So please remember this. Okay, when there is no acceleration, there are two possible reasons why. Number one, either the object is not moving, or number two, the object is moving, but it is moving with a constant velocity. Dia punya kelajuan, dia punya halaju ada tidak berubah. Okay, that's why there is that's why there is no acceleration. Okay, and when there is no acceleration, the net force is zero. If there is an acceleration, means the net force is not zero. Okay, dia either lebih dari kosong atau kurang dari kosong, depending on the direction lah. Okay, so in Form 4, we call this net force lah. But in Form 5, we actually call this net force the resultant force. Okay, so the official name for this net force yang saya cakap tahun lepas kan is actually called the resultant force. Okay, and the resultant force is a single force. Okay, dia adalah one single force that represents the sum of two or more forces. Okay, so bila kita campur semua, okay, the resultant force adalah menggambarkan seolah-olah hanya satu saja force lah, tapi sebenarnya there is two or more forces acting. Okay, so that is what this subtopic is all about lah. Okay, we have seen this in Form 4. Okay, when we talk about net force kan. But now we are really going deeper into it. Okay, when you calculate all the forces, okay, you can actually substitute all the forces as one single force. Okay, like kau boleh tunjukkan, okay, dia punya resultant force, okay, dia punya daya. Dalam bahasa Melayu, resultant is daya paduan. Lepas kamu padukan semua daya, okay, you're left with the resultant force, one single force lah. Okay, yang mewakili semua forces that is acting on an object. Okay, so let's consider this situation. Okay, the situation over here, look at these three people over here, okay, on the left, and these three people here on the right. Okay, and if you notice this diagram, the people on the left are pulling with a bigger force than the people pulling on the right. Okay, so in this situation, we would say that, sorry, my mistake. The people on the left is pulling with the same force as the people on the right. So the resultant force is 0. Because let's say the people pulling on the left, they're pulling to the left with 100 newtons. The people on the right, they're pulling to the right with 100 newtons. Okay, so since the two forces are the same but in different directions, we will say that the resultant force is 0. Okay, seolah-olah ini tidak bergerak lah. Okay, both sides will be stationary. So that's why you see this thing kan, dia tidak akan pergi ke kiri mahupun ke kanan. Please ignore the arrow. Okay, the arrow is a mistake lah. Oh yeah, I should also mention when I change the slide and I'm talking about the slide kan, and if you feel that kenapa ini sir is talking about something that doesn't make sense with the slide kan, please tell me so saya takut itu slide tidak berjalan bah. Okay, so please let me know. Okay, jangan berdiam-diam saja, and also please let me know if you cannot hear the sound of my voice. Okay, all right. In situation 2, we find that okay, so this is the real one lah. So we find that force A is bigger than force B. Okay, look at the arrows lah. And therefore, the resultant force is more than 0. Okay, but it is to the left. Okay, it is to the left. Since force A is pulling more than force B. Okay, in the third situation, we find that the people pulling to B have a bigger force than the people pulling towards the A side lah. Okay, the B side has a bigger force than the A side. Okay, therefore, the resultant force is also bigger than 0. Okay, let me change the color in this. Sorry. The resultant force is also bigger than 0, but the direction now is to the right. Okay, so the resultant force can be more than 0, okay, but the direction of the resultant force is what matters lah. Okay, and of course, the direction with the bigger force will obviously have the resultant force towards that direction. Okay, it's very logical lah. Kalau sebelah satu yang menarik dengan lebih kuat, of course, dia punya jumlah daya itu bila kita pertimbangkan, dia akan menghala ke arah yang lebih kuat lah. Okay, that's very logical lah. So let's consider this lah. Okay, so you have two forces acting on an object in the plane. Okay, so you have this box over here, and you have one force to the right with 5 newtons and one force to the right with 12 newtons. Okay, so the question is calculate the resultant force. Which direction does the object move? Okay, can anybody tell me what is the resultant force? Iqbal, what do you think is the resultant force?
17 Newton to the right.
Okay, very good. Because one is to the right, one is to the right. Okay, so the resultant force, I'm going to use short form. Resultant force is 5 plus 12. Okay, since they're the same direction, and since both is to the right, we assume that right is positive lah. Okay, so this will be 17 newtons, and since they ask which direction, it will be to the right. Okay, very good. All right, so this is an important thing. We not only have to calculate the resultant force, but we also have to tell which direction the force is acting. Okay, and this is very important. So, in actual case lah, kalau saya mau lukis ini balik, if I want to draw this diagram back, what this will look like is, it will be like this. So this diagram, okay, so this original diagram and this diagram is the same diagram. Okay, cuma ini menunjukkan dia punya pecahan daya. Ini adalah just to show you the resultant force. At the end of it all, after you plus everything, this is what you get. Okay, but it means the same thing. Alright, good job. Oh, okay, ada pula jawapan di sana. Okay, let's try this. So a horse pulls a cart with a force of 500 newtons. A farmer helped the horse by pushing the cart with 200 newton force. Okay, so what is the resultant force? Okay, make it a habit. Whenever you say resultant force, also say the direction. Okay, can I have Ava for this, please?
800 Newton force to the right.
Okay, so the resultant force is, sorry, 800 Newton.
700. 700.
Okay, sorry, for a while there, I also thought that I read the thing wrong. Okay, so it'll be 700 newtons. Okay, and as I said just now, make sure that you write the direction as well. Okay, to the right. So it's very simple, left, right lah. But of course, in real life, not everything goes from left to right lah. Kan? Okay, so okay, let's consider this case. Now you have one to the right and one to the left. Okay, you know what? I should have a name list the next time because I cannot really remember. Let me see. Who should I choose? Damir. I haven't heard Damir's voice except for when teacher Rosalind teaches you. Can you tell me what's the resultant force?
7.
Okay, 7 to ke arah mana?
To the right.
To the right. Okay, very good. Okay, and how we calculate this? Okay, take a look at how the calculation is done. Oh dear, look at this horrendous. Okay, so look at how the calculation is done. So we still campur, kita masih lagi campur, cuma kalau dia punya direction of the force is to the left, we write it as -5. Because negative tells us that the direction is to the left. Okay, so very good. So it's 7 newtons to the right. So kalau saya tukarkan ini kepada one single force, the resultant force, I would draw it as this way, 7 Newton. Okay, so that's the number one thing now. Object moves to the right. Okay, all right, same situation, the same horse, but the farmer wants to pull it 200 Newton force in the opposite direction. Okay, so dia mau tarik ke sebelah kiri, but the horse wants to go forward. Okay, let's have Chris Fia. Yeah, Chris Fia.
Sekejap. Calculator. Ni. 300 Newton.
Okay. And the direction of the resultant force?
To the right.
To the right. Okay. Okay, so this is how we would go. But this is a little bit different. Okay, kau tengok. So, in this situation, the person that did this question, dia letak, okay, 500, ini 500, the horse pulling, okay, the person letak to the right sebagai negative and to the left sebagai positive. Okay, but actually you are still correct. Your answer is still correct. It's 300 newtons to the right. Okay, so this tanda positif and negative ini actually kan dia bergantung kepada kamu tau. It depends on you. You decide whether you want the right side to be positive or you want the left side to be positive. Either way also can. Mana-mana pun boleh. Okay, but the standard usually is kalau ke arah kanan is positive. Kalau ke arah kiri is negative. Okay, but is this wrong? No, it's not wrong. It is still correct dengan syarat yang kamu memahami bahawa ke kanan adalah positif, negative. Okay, so the answer is still correct. Still 300 newtons to the right. Okay, cuma dia punya pengiraan sajalah. Okay, dia menggunakan ke kanan sebagai negatif. Tidak salah juga. Okay, so this is a problem now. What if we have one force going upwards, okay, with 6 newton, and then another force going to the right with 8 newtons? Okay, where is the resultant force? Kalau ini adalah saya punya objek lah. For example, if I have a box over here, so saya ada satu orang menarik ke atas sini dan saya satu orang lagi menarik ke kanan. Okay, where do you think this box is going to go? Anybody want to give a try? Just tell me lah what direction you think this box is going to go. Is it going to go to the left? Is it going to go down? Is it going to go up? Is it going to go right? Anybody? Want to just take a guess? Tidak salah tu, Anu. Try.
To the right.
Okay, some people think it's to the right. Sorry, who is this? Siapa yang unmute tadi? Sorry, saya tidak nampak. Okay, so it sounds like Irdina or Patricia though. One of the Patricia sisters, I'm not sure. No, je lah kan Patricia sisters. Okay, so the person said just now, one person said to the right. Okay, why? Why would you say it's to the right?
Because the force is bigger.
Can you give me a reason why you? Okay, because this force is bigger. I think that's a very logical, totally logical conclusion. Okay, since force is bigger, it's probably going to the right. But we cannot forget that there is somebody pulling with these 6 newtons. Betul, dia masih kuat lah. Okay, tapi because there is a force upwards do you think that this box is really going to go like betul-betul to the right kah? What do you think? Is it really just going to go to the right and then like this 6 newtons like tiada effect langsung lah. Dia tidak akan pergi ke atas langsung. Do you think that's going to happen? Okay, consider this. So in actual fact, what actually happens is that we need to do something else on top of this lah. So if the two forces are acting perpendicular to one another, kalau dia adalah 90 darjah, okay, so there is an extra step that we need to do here lah. Okay, so the first thing you need to do is you need to draw a proper rectangle. Okay, draw a proper rectangle. So this 8 newtons is the same as this red color up here. I'm going to change pen. Allah, sorry. Okay, and the black 6 newtons is going to be this one. Okay, so then after that, we draw a diagonal, okay, that represents the resultant force of this one. So this is actually the resultant force. Okay, this is actually the resultant force. So because this guy menarik ke sini, we complete the rectangle or the square. Actually, it's a rectangle lah kan. So sini 8, sini 6 kan. So we complete this rectangle and then draw a diagonal because this diagonal will represent the resultant force. Okay, so while actually sorry, I don't know who answered just now. It sounds like Irdina lah, okay. While actually the answer is almost correct. It is going to go to the right, but it is not going to go to a hard right lah. Okay, dia akan memang miring sikit ke arah kanan. Okay, and this is where this box will eventually go in this direction. Okay, in this direction. And we can calculate this length by using Pythagoras theorem. Okay, which we will get 10 newtons lah. If this is 6 newtons, this is 8, and this is 90 degrees, we can use Pythagoras theorem and we will get 10 over here. Okay, but as I said before, whenever we calculate resultant force, we must also say not just the force but also the direction. So macam mana ni mau cakap direction kalau ini? Going to the upright, going to the right and the up. No lah, not like that. Okay, so what we do is we use apa ni tiba-tiba bahasa Melayu? Hitungkan sudut antara perpenjuru dengan satu sisi bagi segi 4 tepat tersebut. And usually we use this angle. Okay, so how can we calculate this angle? We use cos. Oh dear. Okay, we use cos theta. You can also use sin theta if you want. Okay, but generally we use cos theta lah. Okay, because cos is adjacent over hypotenuse. So cos theta is 0.8. Okay, and then after that you will get theta equals to 36.9. So how do we write the resultant force? Okay, so the resultant force is 10 newtons, okay, and then 36.9 degrees to the horizontal force. Okay, sebab dia menyentuh the horizontal force lah. Okay, we usually use this angle instead of this angle. we usually calculate the direction merujuk kepada the horizontal force. Okay, so try to always use the horizontal force. And this is how we would write. This is how we would write the direction. Okay, sekian sudut to the horizontal force. Okay, so that's kind of the standard that we use now. Okay, so like in this situation okay, we have we have a wooden block, okay, and we have one force over here, okay, and one force over here. Okay, where do you think this box will move? Okay, it will move to the right lah. Okay, it will move this way, tapi dia tidak akan ikut satu atau satu saja. Dia akan macam bergabung. Okay, so this kind of resultant force kan is what this chapter is about lah. Okay, bukan sekadar kiri kanan. Now we want to talk about real life where the forces are at an angle to one another. Okay, but whenever we do an angle, okay, we need to there are two methods to find it. Number one is we use parallelogram, which is what I taught you just now over here. Okay, we complete the rectangle and then we draw the diagonal. Okay, the second method is called a triangle of forces, where you start with the 6 Newton over here. Then lepas itu kamu sambung. So the two forces kan kita kasih sambung the 6 Newton and the 8 Newton, and then after that you complete the triangle, okay, to find the resultant force. Okay, so actually if you think about it, whether you use parallelogram or you use triangle, it is the same okay, it is actually the same thing. Okay, cuma if you ask me, I prefer parallelogram okay, because it's easier to complete the square Okay, it's easier to complete the square and then you draw the triangle, because you know that this force and this force must be the same direction, same length. Okay, and then this force and this force, same direction, same length. Okay, triangle, you want to use triangle, you must remember that the two forces that you are talking about they must sambung one after another. Okay, and then the resultant force is the displacement actually from the start all the way to the end. Okay, so this is the resultant force. So whether or not you use parallelogram or triangle, okay, it's actually up to you But if you are not very sure, I would highly recommend the parallelogram method. Okay, sebab dia senang. Okay. Now, so this is where the real life application happens So you have these two small boats that is pulling on this very huge boat. Okay, and they are pulling, this is F1, 1000 newtons, this F2 is 2000 newtons, and they are pulling at an angle of 60 degrees. So now we are no longer talking about 90 degrees, macam tadi 90 degrees. Okay, in real life, not everything is 90 degrees. Okay, so when these two small boats are pulling at 60 degrees, I want to know about this. Okay, so this boat is obviously going to move forward okay, we know that but I want to know what is the resultant force, and I also want to know what is the direction. Okay, how many degrees, okay, up then to the horizontal force. Okay, so this is how we do it Watch very carefully, because after this you have to do this in the handout that you're going to get from Puan Lim later Okay, watch this very carefully So the first step is you have to set a scale. Okay, so you represent 1 cm to 200 newtons. Okay, for example. Okay, because you're not going to draw 1 cm to 1 newton, right? 1000 cm is a bit crazy Okay, so you represent Kasih wakilkan 1 cm mewakili 100 newton. So the F1 will be 5 cm. Okay, and the F2 will be 10 cm. So you use every centimeter to help you to draw. So you don't have to draw so big don't just draw a scale, then it's fine. So the first thing you do is you use a ruler and a protractor. Draw the two forces from the same point over here. Okay, so force number 1 is 1000 newtons. So this is, look at my amazing ruler, it's 5 cm. Okay, actually it's a little bit more than 5 cm but okay, fine. Okay, and then you draw this as the first force. Okay, 5 cm is 1000 newtons. Then you draw the angle, okay, using a protractor. So if you don't have a protractor in your house, it's a good idea for you to buy it from the koperasi later lah. Huh? Okay, please buy the protractor. Okay, then you find an angle of 60 degrees mengikut kita punya diagram. Okay, and then you draw the second one. Okay, but of course you have to use a ruler as well. Okay, and you have to draw it to 10 cm. So 10 cm is 2000 newtons. So now you have drawn this. Okay, so how do I find the resultant force? Okay, so one of the ways is we use a parallelogram. We complete this parallelogram. So we know that for this one, okay, we measure another 60-degree angle, okay, and then you draw. Okay, make sure that it is the same lah. Okay, make sure that this one and OP and this one over here is the same angle. And then after that, you draw the same length because parallelogram, segi empat selari. And then after that, you complete this thing. 60 degrees again, complete the parallelogram. Okay. So once our parallelogram is complete, we can find the resultant force. The resultant force is the diagonal. Okay. So this is the diagonal. So this is the resultant force. Kita punya kapal ini kan akan bergerak dalam arah begini. Okay. And we can actually find out the magnitude of the force by measuring the whole thing. So when we measure, okay, we will get 13.2 cm. Okay, do you see this? It's about 13.2 lah. Okay, over here. So since 1 cm is 200 newtons, so 13.2 cm is going to be about 2,640 newtons. So this is how we will calculate the resultant force. Okay. And then, of course, we want direction lah. Okay. Oh, sorry. We want direction. Do I need to count the direction? Well, actually, you can count the direction lah, but I don't think you are required to. Macam you don't have to. Kalau dia adalah, if the forces are saying it kan, macam you don't have to calculate the direction. But let me get back to you on that lah. Okay. So if you're using parallelogram method, this is how you would do it. If you're going to use the triangle method, okay, it's also the same thing. Okay, you draw the first one, okay, 5 cm, because it's 1000 newtons. Okay, but the difference is this, you have to sambung, okay, you have to sambung the F2 punya diagram, F2 punya vector from the end of the F1. So it's F1 and then plus F2. Remember vector? Okay, vector, dia mesti bersambung. Okay, if you remember the vector when you learn in admaths with Puan Lim, you know that the two vectors kan mesti bersambung. Okay, and then the resultant vector is the shortcut lah. So, yeah, you calculate this, 10 cm, 2000 newtons. And then after that, you complete the triangle. Okay, the third side represents the resultant force, which is this. Okay, exact same thing. You will get the exact same thing, cuma different method lah. One is a parallelogram method, one is a triangle method. Okay, you have to know both methods. But if I were you, if you are given a choice, okay, if I were given a choice, I would choose parallelogram. Okay, I actually prefer parallelogram lah. It's easier. Okay, so you will still get the same thing, 13.2, and then you get 2,640 newtons. Okay, so so I want you to I don't think I have enough time, so I must finish this now. So I'm just going to show you this again. Same thing. So F1 is 4,000, F2 is 3,000. Okay, this is 4,000, this is 3,000. Okay, and then of course the angle is 50 lah. Determine the magnitude of the resultant force. Okay, so this is where I will teach you how to find the direction. Okay, but tell me first lah, if you're going to draw this, kalau kamu ada 4,000 newtons and 3,000 newtons, can you suggest for me a suitable scale? What is a suitable scale you want to use? 1 cm mewakili how many newtons? Anybody want to suggest? 1,000 newton. Okay, I think 1,000 newtons is very logical lah. So you don't have to draw so big lah. Okay, can I use 1 cm as 500 newtons? Can, also can, no problem. But it's going to be very big lah. Okay, so you don't have to draw too big, but don't draw too small. Okay, don't don't. Yeah, I know some people can't. Don't draw 1 cm mewakili 2,000 newtons. So over here you only draw 2, and then over here you only draw 1.5. Okay, too tiny lah. Jangan terlalu kecil lah. Okay, but in this example, they're going to use 500. Okay, so 500 means you are going to have 6 cm for the 3,000 newtons. Okay, ini salah sudah ini actually. Dia terbalik. Anyway, it's okay. So same concept lah. You draw the parallelogram, you finish it. Okay, everything is 50 degrees, 50 degrees, 50 degrees. Ini actually silap sudah. Dia tersilap ini. Okay. But the method is still the same. Complete the parallelogram, okay, and then draw the diagonal. Then you measure the diagonal. So the diagonal, according to this one, is about 12.5, maybe. Yeah, 12.5. And in order to find the amount of force, you multiply with the scale yang kamu pakai tadi. Okay, so you get 6,250 newtons. So the question now is how to find the direction. Okay, so this is something that I didn't cover just now, and I'm going to use this example to cover lah. Okay, how do I find the direction? Oh, tidak payah pula. Sorry. Okay, fine. Never mind. So in this direction. Oh, that's interesting. I didn't know that you didn't need to find the direction. Okay, never mind. Yang paling penting, find the resultant force. Okay. Okay, so this one is complete the diagram using the resultant force by using the triangle method. Now remember, triangle method, although it is triangle method this one can be used. Okay, so if you see this one is triangle method because the direction of the arrows bersambung. Okay, then the resultant force is they akan complete the triangle lah. But in the case of this one, okay, you cannot because the direction of the forces are opposite ends. They are not bersambung. So how do I make it bersambung? Okay, I pindahkan here to this one. Okay, saya pindahkan sini ke sini. So ini saya akan dapat bersambung lah kan. So where is the completion? The completion is this direction. Okay, so be very careful lah. Take a look properly at the direction. Take a look properly at the direction of the arrows. Okay, especially if you're going to use triangle method, make sure that the arrows dia bersambungan. Okay, then you complete. But if you're going to use parallelogram method, kalau kamu mau pakai kaedah segi empat selari, then no problem lah. Okay, just make sure you have a parallelogram, baru kamu draw the diagonal. Okay, so just have to be careful with both the methods lah. All right. Okay, let's consider this situation. Okay, so we come back to a simple situation, tapi ini melibatkan atas dan bawah lah. Just now we considered left and right, and then we considered saying it and saying it. Now we talk about up and down. The total weight of the lift and passengers are 6,400 newtons. So this way downwards. Okay, what is the tension of the lift cable? Okay, this is the tension. Dia tarik dia ke arah atas is 8,000 newtons. What is the resultant force acting on the lift? Okay, let's see. Can I have I don't know. Isabella, are you there? Isabella?
Yes.
Okay, what is the resultant force? What do you think is the resultant force on this lift?
I think it's 1,600 Newton.
Okay, to which direction?
To the right. to up. To up.
No,
To the
okay,
right.
okay. It's to, no,
Positive
lah.
point.
Cannot be to the right lah, kan? Okay, okay. Thanks lah. Yeah. So actually, so last time when I was younger, kan, this is what I used to write lah. Okay, and my teacher always laugh at me lah, to the up. Okay, tak boleh ah, jangan lah. Okay, yeah, don't. Teacher Rosalie is next to me, so she will scold you if you write to the up. Okay, upwards lah. Okay, so 1,600 newtons upwards. Okay, jangan ikut saya. Don't write to the up. Okay, tiada ini to the up. Okay, to the up, to the down, no lah. Okay, upwards and downwards. Okay, this is how. Okay, very good. All right. This is something that we learned last year, but I'm just going to ulang kaji this year because it's also something that you have to know. So whenever resultant force is zero, we know that there are two cases. Okay, number one is if the object is not moving. Okay, so I want to introduce to you several new terms lah. Number one is if there's something that is not moving, there's obviously the weight lah, weight yang kita belajar dari tahun lepas. Okay, but according to Newton's third law, okay, every force, every action must have an equal and opposite reaction. Okay, so that's why this weight, the weight, the force is downwards. So the reaction force, it is the same magnitude as the weight. So if the weight is, let's say, 10 newtons, the reaction force is also 10 newtons. Baru dia seimbang lah, kan? Imagine if there is no reaction force. What's going to happen to this book? The book is going to go downwards all the way sampai ke jana lah, kan? Dia akan bergerak ke bawah. Okay? That's why your book is able to remain stationary because there is a reaction force from the table that is stopping it from going down. Okay, and this law applies everywhere. When there is a force, there must be a reaction force in the opposite direction, but the same magnitude. Okay, equal and opposite direction. Same thing with this car. Okay, it is not moving, so the velocity is zero, the acceleration is zero, so the resultant force is zero. So therefore, there are only two forces acting on this car, which is the weight of the car and the reaction force. Where is the reaction force coming from? If the reaction force is coming from the table, what about the car? The car's reaction force is coming from the road. Okay, the road is pushing the car up. Okay, although we don't see the road pushing the car, but that's actually what the road is doing. It's actually giving a reactive force. What am I drawing here? Oh my word. Okay, next. Moving object. Okay, now even in a moving object, notice that the weight and the reaction force is still there. Okay, so no matter what happens, the weight and the reaction force is still there and it is equal. Okay, so in this case, the weight and the reaction force is the same. Weight and the reaction force is the same. That's why your car doesn't go up or go down. Okay, but in this first case, if the acceleration is zero, okay, and as I mentioned just now, acceleration zero means velocity is constant, resultant force is zero, which means that your force to the front and the force to the back is the same magnitude. Okay, and in a moving car, we call this force to the front an engine thrust. Okay, dalam bahasa Melayu is called tujah engine lah. Okay, so daya yang menolak kereta itu ke depan is called the engine thrust, and the behind force, the force that is pulling it back, is frictional force. Okay, but actually if you think about it, there is another force juga ini yang menghalang this kereta. Okay, which we call air resistance. Ini kita ada cakap tahun lepas lah. Okay, but let's not talk about the air resistance now lah. In reality, obviously there's air resistance. Okay, but since we are talking about the jalan raya, we call this the frictional force. Dalam bahasa Melayu, frictional is geseran. Daya geseran. So kalau daya tujah ke depan, if the engine thrust is the same as the frictional force, then the resultant force is zero, acceleration is zero. So although this thing is moving, it is constant velocity. Okay, dia mesti ikut this urutan and dia mesti satu kali datang itu. Okay, acceleration 0, resultant force 0, acceleration 0, moving with constant velocity. Okay, now if the velocity is increasing, means ada acceleration. There is an acceleration now. If there is an If there is an acceleration, okay, that means that you're going to have the resultant force is more than 0 lah. Okay, so your engine thrust is bigger than your frictional force. That's why it can accelerate, because the resultant force is no longer 0. So the resultant force is the engine thrust tolak dengan the resultant force to the back. Okay, just like the case of this one is 12 newtons and this one is 5 newtons. Okay, cuma dalam kes kereta ini, the 12 newtons is the engine thrust. Okay, daya tolakan hasil daripada engine lah. And then the frictional force is because there's geseran. There's always friction between the tire and the road. Okay, so it's this back force. So the resultant force is to the front. Okay, if it is accelerating. Okay, remember, there is a resultant force only if there is an acceleration. Sorry. Yeah. Okay. Yeah. Okay. I want you to take a look at this diagram. Okay. And I want you to, now we talk about up and down now. So there are two forces that are in play here. Number one is the weight. Okay. But the force upwards is no longer called reaction force, because our, what is this thing called? A drone. This drone, it is now, we're talking about up and down movement lah. So if something is moving up and down now, we don't talk about reaction force. Okay, bukan macam tadi, if it's a car kan, but we're talking about the left and right movement. So the weight and the reaction force mesti ada. That's why the car doesn't go upwards lah. Okay, but now since we're talking about drone, okay, so if there is a weight okay, that is pulling it down, the upwards force is called the lift force. Okay, the lift force, daya angkat lah. Okay, okay. I want you to take a look at this jadwal, okay, and then I'm going to call on 9 people or 3 people okay, to help me to answer each section dari sini ke sini, dari sini ke sini, dari sini ke sini. Okay, I'm going to give you 2 minutes. Just take a look at this. Tell me what is the answer for this. So the 3 people is suggested from Teacher Rosalind, not my suggestion. So, okay, first person is Jacinta. Okay, see, Teacher Rosalind remembers you, so that's why she called your name. Okay, Jacinta, can you tell me this situation? Stationary on the ground. Do you think the acceleration is 0 or more or not 0?
The acceleration is equal to 0.
All right, very good. I really hope that I can show this. Okay, what about the resultant force?
The resultant force is equal to 0.
Okay, and then the comparison between the forces?
The lift force is equal to the weight.
Okay, lift equals to weight. Sorry, I'm going to use L and W now because my writing is so horrible. Okay, thanks, Jacinta. Okay, next person who is doing this one, okay, move upwards with acceleration is Miss Shim.
Acceleration equal to 0.
Equals to 0.
Yeah, I don't know.
What about the resultant force?
0.
0 also, okay. Comparison between the forces?
Lift force is bigger than weight.
Lift force is bigger than weight. Okay, don't worry, we will check the answer later. Okay, the third and the last person yang Teacher Rosalind ingat adalah Louis. Yeah, Louis, are you there?
Yes.
Okay, first one.
The acceleration equals to 0.
Equals to 0.
Resultant force does not equal 0.
Not equals to 0, okay.
The lift is bigger than weight. The
Lift
force
is Lift force is bigger than weight. Okay. Okay, thanks everyone. Okay, let's check. So the first situation is acceleration equals to 0. Okay, so good for Jacinta. Okay. The resultant force is also equals to 0. Okay, very good. Okay, and of course the weight is equals to the lift force. Okay, so that's the first situation. So Jacinta is 3 for 3 lah. Okay, good job. So in the case of something that is stationary, okay, everything is 0. Okay, and the weight is equal to lift force. Okay, all right, let's go to Shim's one. So this object is moving upwards with acceleration. So the acceleration is, oh, sorry, we have to talk about Louis one first. Okay, fine, Louis. Move upwards with constant velocity. Acceleration equals to 0. Okay, so that's 1 for you. What about the resultant force? The resultant force actually is 0. Okay, so whenever the acceleration is 0, the resultant force is also 0. Okay, so be very careful with this. You cannot say that it's just because it is moving doesn't mean that the resultant force is not 0. Okay, so we have to really watch the words carefully. If something is moving with a constant velocity, the acceleration is 0, the resultant force is also 0. Okay, something that we have to constantly remember, because it's when we think about it, it doesn't make sense to us. But when something is moving, sure, the resultant force is not 0. Okay, but actually in terms of physics, it is not like that. Resultant force is 0 means there's no acceleration, whether it is moving or not. Okay, I suspect that this is something that I will be constantly shouting at you all in this chapter. Okay, don't forget, acceleration 0 means resultant force is 0. Okay, so yeah, please be careful. All right, what about the last one? If the resultant force is 0, the lift force is equals to the weight actually. Okay, so this is also wrong. Okay, so unfortunately for Louis, you only got 1 out of 3. Okay, so this is something we must remember. Even if the thing is moving upwards with constant velocity, okay, it doesn't mean that the lift force is bigger than the weight. Okay, the only way that the lift force can be bigger than the weight okay, is if there is an acceleration, which brings us now to Shim's answer. So Shim said that the acceleration equals to 0. Actually, the acceleration is not equals to 0. There must be acceleration. Because dia sudah cakap pada sini with acceleration, ada acceleration sudah. Okay, so the acceleration is not equals to 0. There must be an acceleration. If the acceleration is not equals to 0, means the resultant force also not equals to 0. Okay, means not equals to 0 means ada nombor lah, dia bukan kosong. Okay, and because of that, the lift force is bigger than the weight. Okay, so that means Shim also got 1. Apa ini? Sorry. Shim also got 1 out of 3. Okay, so yeah, our winner is Jacinta. Clap hands, begitu. Okay, so the thing we need to learn from this please remember this, especially this third one This third one is the one that I suspect that it will take some time for us to get used to this. It doesn't mean that if something is moving means that one force is bigger than the other. Okay, the thing that determines, benda yang menentukan sama ada resultant force atau tiada is acceleration. Asal ada acceleration means there is a resultant force. If there is no acceleration and the thing is moving, okay, tapi tiada acceleration means the resultant force is 0. Okay, all the resultant force kita combine campur semua sama dengan kosong. Okay, it's the single most important thing that you must remember from today's lesson. Okay, all right, I think that's it for today. I want to stop here today because we have another class tomorrow.